the next little bit of this that I want us to understand is a little bit more about brain structure and function. As we know, our brain is made up of neurons, and these neurons communicate with each other using both electrical signals and chemical messengers, so those neurotransmitters. For the purposes of this class, while I'm not going to give us a very strong overview of a lot of these, we are going to be talking about neurotransmitters as this class goes on. You may have heard this idea that psychological disorders are just chemical imbalances. While that may be an oversimplification and not exactly true, what they're really saying is that we know that there are some neurotransmitters that are involved in psychopathology. So you might have heard about things like, the reason why people take antidepressants is to increase their serotonin, and that must mean that serotonin is involved somehow or another in depression. That's really what they mean by that. And I want us to get away from just thinking that there's just chemical imbalances, because that's oversimplified and is not exactly true. In addition, since we're talking about development, we have to really consider how things are changing over time. So the brain is a lot more malleable and shifting a lot during early childhood. And that's why things like having an adverse childhood event, such as abuse, can actually have some more longer lasting impacts, because our brain is a lot more plastic at that time. In addition, we know that there are things like growth in our neural connections, but also we have to prune or remove some of those connections that are no longer useful. So we'll talk about this a little bit more when we talk about autism, because there's actually some theories about autism that have to do with that growth and pruning, and that those things may go a little bit awry in children who go on to develop autism. So we do know that there's been a whole host of changes in the brain that have been associated with certain types of disorders. So things like having frontal lobe dysfunction, or things that aren't working quite as well in the frontal lobe, which all deal with like inhibition of our impulses, may actually be deficient in children who have ADHD. Or again, that there may be changes in the serotonin system in children who have depression. And we have to think about that there are multiple influences even on those brain changes. As that video is demonstrating, we really have to think about that there are environmental changes that can influence it, as well as genetic changes that can influence those things. So to just do a little bit of an application to Valerie's case, is that we know that there are certain things that are happening in the brain of children who have ADHD. So she may have ADHD based on some of those early reports of that hyperactive and impulsive behavior. And so some of the things that we know is that there are areas of the brain that are implicated. So things like working memory, so in the prefrontal cortex, I'm just kind of putting them together, this prefrontal cortex, a lot of working memory, complex decision making, so maybe having a harder time controlling those impulses, as well as the parietal cortex, being able to actually control and deploy attention to different things. All of those things have been implicated in children who have ADHD. So this may be happening with Valerie. We don't really know, but there's an assumption here that some of this could be happening also in Valerie's case. And so if she's having difficulties with that working memory, if she's having difficulties with a lot of this complex decision making, that may influence her choices that she has and what choices she starts to make as she grows up. I'm going to stop this video here since we just talked about the neurobiological aspects, and continue on in our next video.